All right, this is the first of a few videos on physics formulas and topics. So this topic is motion in one dimension along the x or y axis. We're talking about like a car going along, a person running, bowling ball rolling, for example. If v is constant, velocity is change in distance over time. If a is constant, we've got a series of equations that we can use for that. I'll go over those in more detail if necessary. One worth pointing out is that total distance over total time is average velocity, which is v final plus v initial over 2. That'll come in handy as a shortcut. Don't forget that acceleration is just a change in velocity. Velocity is speed in a given direction. So if the direction is changing, the speed is the same, then we're good. Negative acceleration horizontally is slowing down. Vertically, negative acceleration means accelerating downward. So in the case where a person's throwing something up in the air, straight up, straight down, I drew the line so that it's not covering itself, so you could expand it a bit to show that velocity up at this height is equal to the velocity on the way down at that same height. So every velocity, every corresponding height has the same velocity in opposite direction. On the way up, it's positive. On the way down, it's negative. So if you consider this, v final equals negative v initial. All right, so the case where you're going to throw something straight up in the air, worthwhile to point out is at the top, the velocity at the top is 0, but the acceleration is still negative 9.8. We know this acceleration is true because the thing slows down on the way up, stops, and then speeds up on the way down. So little quick shortcut, time up to the top is equal to v initial over g. So if you think about g as 10, negative 10, v initial, 10 meters per second squared, the negative sign only implies direction, so we can leave it as positive 10. So if you throw something up with a velocity of 30 meters per second, it takes about 3 seconds to get to the top. And then it'll take another 3 seconds to get back to the bottom. So that's what this is saying. The time up plus the time down is basically 2 times the time up. All right, so in this case, where we're looking at dropping something off some building at height h, the velocity at the bottom, if v initial is 0, the velocity at the bottom is square root of 2gh. Remembering that height final here is 0, height initial is whatever the height of the building is. And then v final equals square root of v initial squared plus 2gh if v initial is not 0. In other words, it throws it up first and lets it come down. Don't forget your sign convention there, because one of those is positive up and the other is negative down. So if v initial is 0, v final is square root of 2gh like we talked about down here. Okay, only if v initial is 0, time to the ground if dropped is square root of 2h over g. And the distance dropped is negative 4.9 t squared. So if you think about that, 4.9 is about 5. So 5t squared, if it falls for 1 second, it's 5 times 1 squared, or 5 meters. Falls for 2 seconds, it's 5 times 2 squared, which is 20 meters. 2 squared is 4 times 5 is 20. 3 seconds, 3 squared is 9 times 5 is about 45 meters. Got it? Okay, so if you just take your time that it fell, square that, multiply by about 5, you're going to get about the approximate distance that it fell. So if v initial is not 0, then the time of flight can be found using the quadratic, where a is negative 4.9, b is the initial vertical velocity, and c is the initial height. There's the quadratic. Have fun.